Hi, I'm Ms. Wong. Today we're going to look at combinations of transformations. If you haven't seen the previous two videos, please do so. It talks about translations and dilation and reflections. Today we're going to combine those three things together. Translations. So we're going to look at positive translations and negative translation. And we're going to use two methods today, the coordinate mapping and substitution. Substitution is like skipping some steps. So coordinate mapping is what we've done in the previous videos, where x, if we're moving in a positive direction, becomes x plus h. And then what do we do in the previous video? We rearrange so that we get the original x, and then we substitute it into the equation to see what it looked like. In substitution, we go straight from x and substitute the equation into as x minus h. So no rearranging. Same thing with the y. And for negative translation, again in coordinate mapping, we can see that the image was x minus h and y minus k. But in substitution, we go straight away to substituting x plus h and y plus k. It makes sense because remember, after we obtain the image, we rearrange our x in terms of x dash, and we would have gotten x plus h. So it's the same thing, but it's like skipping a couple of steps. Dilation. So with translation, if we translate x, we're changing x. But with dilation, if we're dilating from the x-axis, we're changing the y. So dilating from the x-axis, we have ay. And if we substitute, you substitute the y with the y over a straight away. We can see that. So see, dilating from the x-axis, away from the x-axis. See this arrow? Away from the x-axis. It's changing the y value. See, 1 becomes 2. Whereas dilation from the y-axis, see, going away from the y-axis, we can see that the 1 becomes 2. It's the x value that changes. So again, the coordinate mapping, we would write the coordinate in the image, and in the substitution, we just substitute in the equation with x over a straight away. And then the third thing we're going to look at is reflecting in the x-axis. Again, if this is the mirror reflecting in the x-axis, we can see that the one that changed into a negative is the y value. So we have negative y for reflecting in the x-axis. And with replacement, it looks exactly the same, so we don't have to worry too much about that here. And reflecting in the y-axis, see this point here becomes that point there. So 1, 1 becomes negative 1, 1. It's the x value that changed. Reflecting in the y-axis is the x value that changes. And again, with substitution for reflection, it looks pretty much the same thing. So let's do an example. Find the equation of the image y equals x cubed after it undergoes the following sequence of transformations. I'm going to call this 1a because I'm going to do this exact example, and instead of using coordinate mapping method, I'm going to use the substitution method. So let's have a look. So we start with y equals x cubed. What are we doing? Translation of 3 units in the positive direction, x direction, so moving x by 3, so x plus 3. And 1 unit in the positive y direction. So my new y is y plus 1. Next, we said reflection in the x-axis. So what does that mean? Remember, reflection is changing the y. So that part becomes negative. So negative y plus 1. Don't forget brackets. And then dilation by a factor of 2 from the y-axis. What does that mean? 2 in front of the x side. So don't forget brackets. Now, we're going to do the x. So x dash is equal to all of that. And then we rearrange to get our original x. So bringing the 2 over, then minus 3. So now we have x is equal to that. Do the same for the y. So y is equal to all of that. Bring the negative over, minus the 1. So y is equal to that. Now we plug these 2 into our equation. So our y is now minus y minus 1. And our x is now x over 2 minus 3. Something like this. Bring the 1 over, becomes plus 1. And then multiplying by negative to get rid of that negative on that side, we obtain that. Let's see what happens when we use the substitution method. So y equals x cubed. So when we say translate it 3 units to the right, and it means we're adding to x, so we're going to replace x with x minus 3 and y with, moving 1 to the positive direction, y minus 1. So we replace it, we have y minus 1 and x minus 3. Then it says reflection in the x-axis, means we put a minus in front of the y. So we're playing that. And next we say dilation by a factor of 2 from the y-axis, means we replace our x with x over 2. And we obtain that. Then we move the 1 over and multiply by minus. We can see that we get the same solution. So it's really up to you whether you use the substitution method or the coordinate method. Pick one and practice it. Let's do example 2. Example 2. In this example, I've rearranged these 3 sentences to observe what happens if they get rearranged. Do we get the same equation? Let's try it. Find the equation of the image of y equals x cubed after it undergoes the following sequence of transformation. A dilation by a factor of 2 from the y-axis, followed by a reflection in the x-axis, followed by a translation of 3 units in the positive x direction and 1 unit in the positive y direction. So let's see, dilation of 2 from the y means the x changes by 2. Reflection in the x means the y becomes negative. And now a translation of 3 in the positive x direction, so add 3 to the x, and 1 in the positive y direction means add 1 to the y. Now x dash is equal to that, and then rearrange, minus 3 divided by 2. And then y dash is equal to that, rearrange, minus 1 divided by minus y, minus times y becomes minus, minus 1 times minus becomes positive 1. Now plugging these two into the original equation of y equals x cubed, so that becomes over there and that goes over there. Now I'm bringing the 1 to the other side and multiplying everything by minus 1. We can see that it's not the same as the 3 sentences in the other order. I want to show you what it actually looks like. So here are the 2 examples side by side that we've just done. Example 2 is the one we just did. And let's have a look at example 1, what it actually looks like and why the equations don't match. So if we translate 3 units in the positive x direction, that means we're moving to the right. And 1 unit in the positive y direction means we're moving up. And then followed by reflection in the x-axis, so the x-axis mirror it. And now a dilation by a factor of 2 in the y-axis, so it's going to get wider. So that's our final graph. Let's have a look at the other one. So starting with a dilation this time, the reflections in the middle and translation last. Let's see if it's different. So original graph, x cubed, dilating by 2 from the y-axis, means we're getting wider straight away. So far it could look the same, right? But let's see, reflecting in the x-axis means it flips. Now translation of 3 in the positive x direction means 3 that way. And now 1 in the positive y direction means going up. And so you can see that this graph is not the same as this graph. So the order really matters. Make sure that you don't try to do things in the wrong order, because you'll end up with 2 different things. I hope that was clear. If not, comment down below and I'll try to clarify that. Try the examples again to see if you get the same equation as me. Thanks for watching and I'll see you next time. Bye!